Hello everybody, my name is Lev Kononenko. Welcome to UPSTREAM upstream training. I will speak about waterline logging. The first thing I want to tell you is waterline logs, e-logs. We use electronic methods to perform and indirect analysis of the feature of the well formation. On this we can see devices. Number 1, casing, waterline cable, downhole probe, first sensor, second sensor, third sensor, and measurements obtained by a sensor. Caliper log. Variations in body hole diameter are important in waterline log interpretation. The inner diameter of the well is measured by caliper log. Gamma ray log. The measurement of radioactivity allows use to identify the lithological composition. For example, a large amount of gamma rays emits shale. A small amount of gamma rays emits clean sandstone. Continuous potential log. Porous sandstones with high permeabilities tend to generate more electricity than impermeable shales. So using spontaneous potential log, we can indicate the permeabilities of rocks in the well and visually interpret it to show formation, bed boundaries, and thickness. Resistivity logs determines what types of fluids are present in the reservoir rocks by measuring how effective these rocks are at conducting electricity. Resistivity is the inverse of conductivity. Resistivity is expressed in Ohm meter. Conductivity is expressed in Hose meter. Fresh water and oil are poor conductors of electricity, high resistivity. Most formation water are salty enough, conduct electricity with easy, low resistivity. A porous and permeable formation with very high resistivity, inferred to have hydrocarbons. Types of resistivity logs. Lateral focus log sends a current outward to a rock. Accurate is measuring thin beds. Indication log. A current is indicate its formation beds by a magnetic fields. Accurate is measuring thin beds. Microresistivity log. Show resistance very close to the wellbore. Has two curves, one of filter cakes resistivity and one less, 0.5 feet into the formation, in two curves not equal, invasion. Sonic logs, also called body hole compensated, determine porosity by measuring how fast sound waves travel through rocks in the well. In general, sound waves travel faster through high-density shells than through lower-density sandstones. Density logs, also called formation density compensated, or little density log, bombards formation with gamma rays. Denser formation absorbs more gamma rays. Determine porosity by measuring the density of the rocks. Estimate the porosity of rocks that contain gas that result in crossover of the log curves when paired with neutron logs. Neutron logs, also called compensated neutron logs, determine porosity by assuming that the reservoir pore spaces are filled with either water or oil and then measuring an amount of hydrogen atoms in the pores. Underestimate the porosity of rocks that contain gas that result in crossover of the logs curves when paired with density logs. Matter logs determine the orientations of sandstone and shell beds, faults and fractures in the body hole. All depth matters measured the resistivity of rocks on at least 4 sides of the body hole. Modern depth meters actually makes a detailed image of the rocks on all sides of the body hole. Body hole scanners, UCI, use sonic. Formation microscanner and formation microimager use resistivity. STAR uses sonic and resistivity. Nuclear magnetic resonance. utilizes technology used in the medical field. Measure the magnetic response of fluids present in the pore spaces of the reservoir rocks. Measure both porosity and permeability, as well as the types of fluids present in the pore spaces. Thank you for your attention. Good luck.